Okay, we're going to take a look at even and odd functions. This will be the last thing that we're responsible for on this little assignment slash test I'm going to be giving you on Wednesday. So we'll take a look at even functions. Now, all you're going to have to do is sort of recognize these by looking at graphs in this particular instance, and this is not going to be internal stuff, but this is just stuff for next year more than anything else. But even functions. So a function is said to be an even function if its graph is symmetrical with respect to the y-axis. It basically means that you can flip the graph around the y-axis, right? Here's my y-axis. So you can flip it around. That's like a line of symmetry, if you will. So you can flip it and it will map back onto itself. So there's a line of symmetry is our y-axis, and we can flip the graph around that and it will be basically mapped back onto itself. So we'll have a look at what that looks like. I'll just bring this Desmos. This is the link that's in there. So when you go to do this page, and when we do this together, we might just have a look at this. So here's just a quadratic graph, and I'll play it real slow for you. But if we flip this quadratic graph around the y-axis, right? We already know this, but this is a fairly straightforward example. See how it just flips around and maps back onto itself? Yeah? So that's what we call, it reflects around the y-axis. That's reflective symmetry, and the y-axis is the mirror, the line of symmetry. So any graph that does that is going to be an even function. And the other thing is that there's a hint in here, because most even functions have an even kind of exponent. So you're dealing with polynomials. Even functions would be x squared, x to the 4, x to the 6, if you're dealing with polynomials, but we're not always dealing with polynomial graphs. So that's what it would look like. What else? You can go through this student activity, and if I was to just sort of show you what's in there, it's just a little nice play around. Here's a moving. This is not obviously a quadratic. Not even sure what kind of function it is at this point, but it doesn't matter. Is it an even function? Well, if it flips itself around the y-axis and then maps back onto itself, then it's an even function. So this is an even function. Regardless of what kind of function it is, it's even. This one is not an even function, okay? We'll talk about what that one is in a sec. And then this one is, oops. Let's just turn that off. So is it an even function if it will basically map onto itself by flipping around the y-axis? So that's an even function. So this Desmos activity basically is for both. Probably should put it at the end here more than there, because it shows both odd and even functions. But anyway, I don't want that. We'll put that in here. So even functions, they flip around the y-axis and map back onto themselves. There's a graph here, a graphic, where basically this is the kind of thing that you would be asked, which of these graphs represents an even function? And you should be able to sort of visualize it as to which one of these you think would flip around the y-axis and map back onto itself. So basically, this one, no. This one looks like it will. This one is symmetrical about the y-axis, and this is in fact symmetrical about the y-axis. So those three are even functions. Regardless of what kind of function they are, they're even functions. That's what it means to be even. Odd functions. Okay, so odd functions do something quite different. If you want to have a look on this Khan Academy link, this is where I got some of this information. But odd functions, cubic functions are odd functions. That would be the most common one. And guess what? See, the exponent's odd. So we'll take a look at what an odd function does, and it's about rotational symmetry in this particular case. So if we go to this odd function Desmos thing, and we play this, So here's the cubic, and what happens is this is not symmetrical about the y-axis. So if I flip it about the y-axis, it's not symmetrical. So that's a flip around the y-axis. But then I flip it around the x-axis. So it's two flips, which is basically a rotation of 180 degrees, right? So I flip it around the y-axis. That's not even. It doesn't have that kind of symmetry. But then I flip it again, and this time I flip it around the x-axis. It has what we call rotational symmetry of 180 degrees. So if something has rotational symmetry of 180 degrees, we call that an odd function. And so we need to find graphs that have that kind of ability. Cubics definitely have that kind of ability. And those are the most common ones, but they're not the only ones. So we have graphs here, a little bit harder to see. Well, this one definitely is not, because this one looks to be even, right? Well, we know cubics are. So the question becomes, can we rotate that 180 degrees? So flip it in the y-axis and then again in the x-axis. Can we flip that around 180 degrees so that it maps back onto itself? Yes, we can. So a lot of linear functions are odd functions. Well, and that's because of that, right? Y is equal to x1. That's a linear function. And this is x3, that's a odd function. That's not, and we don't know what function this is, but if you were to take a piece of paper and flip this 180 degrees, it would flip back onto itself. So that one is as well. So those are odd functions, and basically there's nothing, I mean, you can go into the Desmos thing here, the student one, and have a look. This is kind of important, that basically you're flipping. This represents flipping over the y-axis, but also flipping over the x-axis. So you're basically doing like a double flip, which is two flips of 180, which is equivalent to 180 degrees. So you basically have this statement here with odd functions, and with even functions, you basically have this kind of statement. A function of f is even if f of x is equal to f of negative x for all possible x values. And by the way, function notation is f of x. We use f of x instead of y. Basically, that's all you need to know at this point. So you see f of x, that means we're dealing with a function, and basically y is equal to f of x. That's how we just, instead of writing y, we just write f of x. And so this is function notation. This is an example of an even function. This is an example of an even function, even function, even function. They have symmetry around the y-axis. An odd function has a rotational symmetry, or a rotational symmetry of 180 degrees. In other words, it will rotate around itself 180 degrees and map back onto itself. So here's an example, here's an example, here's an example. And all you're going to have to do is identify some graphs that are either odd or even in their capacity, and as we classify.